If there was a complete problem with the altitude setting, you just wouldn't see anything, or you could be getting misreadings.
For those of us who are tech obsessed, the rollout of 5G, which is the next generation of wireless connection, is an exciting time. It has the potential to connect millions of devices at ultra-fast speeds. But in America, the aviation industry is concerned the service may interfere with aircraft technology and is now trying to sort the problem out.
We put out a report in 2020 that said that there was a significant danger or a significant impact if this danger is realized, including the loss of an aircraft and casualties.
Al Season is the Vice President of the Radio Technical Commission for Aeronautics, or RTCA. It's a US non-profit organisation that develops technical guidance for use by government regulatory authorities and industry. And there's one piece of equipment that's causing the most concern.
The radar altimeter is used close to the ground in low visibility conditions in order to allow the crew to understand how far they are above the ground before they land the airplane. And if that radar altimeter gives them bad data, they may think that they are higher than they are and could descend into the ground.
So are people in danger right now?
No. Right now they're not in danger because the aviation industry and in the United States put out some changes to accommodate if the 5G transmitters went live close to airports.
The telecommunications companies have agreed to delay the turning on of 5G around sensitive airports, giving the aviation industry more time to come up with a plan. But to really understand the problem, we need to know how 5G and altimeters operate. I'm starting at City University in London with Professor Richard Curran.
I have a very special seat for you, which is co-pilot.
Oh.
I'll sit on the left side as the chief pilot in case you're
I
not
crash.
sure where some of the buttons are. Go ahead.
Is this the real size?
Yep, this is your spot.
Okay.
Just try and climb in as best you can.
Right. Oh, all those yoga lessons paid off, Ricky, that's for sure.
Are you comfortable?
Very.
There's a lot of instrumentation wrapped around you. What you can see here, we both have the same thing. Here on the right-hand side, you have the ability to see like the orientation of the aircraft, like a compass type mechanism. Other things, obviously, you want is speed. So we have that on the left-hand screen here. On the right, you've also the rate of climb or the rate of descent. But the big thing that we're interested in today is right in the middle of the screen, the altimeter.
So what is an altimeter?
To make it as simple as possible, a signal is sent down, it bounces back from the surface of the Earth. And when you, of course, understand and know the wavelength of the signal and the time that it took to bounce back, you can measure then the altitude of the aircraft. This is absolutely critical, especially on landing and takeoff, so that you can anticipate how you need to control the aircraft, the speed of the aircraft, the flap settings, the yaw, dealing with also wind conditions, etc.
Another simulator next to the Airbus helps illustrate just how many decisions must be made on takeoff and landing, and lab manager Dr. Chetan Jagadish is lending a hand.
Let's start our running. Here we go, Chetan. Off you go. So we're already at a certain speed of knots here, 103, 102, so airspeed. This gives us an idea of the thrust setting. I mentioned in the middle of the screen, typically then you have the orientation. So that's either moving left, right, or sort of up and down. But this is the key one you're interested in, the altimeter. If a pilot is depending on a correct assessment of this altitude, and this altitude reading is incorrect, and that is actually read incorrectly by the computer as the system running well and saying, oh no, the ground wasn't as far away as we thought, because there was an interference came in from a 5G system.
So the computer wouldn't be telling him all the instructions that he would need, or he or she would need to land
The computer could
the
actually
plane.
be telling him the wrong thing. The other classic, of course, is nighttime. So we've set the visibility to 20% here. If there was a complete problem with the altitude setting, you just wouldn't see anything here, or you could be getting misreadings. So you can see with visibility, the pilot cannot depend on what they're seeing, and there it is. That was a bad touch.
But it does show, just, you know, especially at night time, when you'd be flying blind if your altimeter starts to play
You're
up.
exactly right. You're essentially flying blind. You're hoping that your intuition and the gods are with you.
So now you know how an altimeter works, let's look at why 5G could affect its radio waves. And just to clarify that the G stands for generation. It doesn't stipulate the technology involved. As the numbers have gone up from 3G, 4G and now 5G, the bandwidth has widened, hugely increasing the rate of data transfer with each new generation. But in an industry that prioritises safety, how was this able to happen?
So in the United States, the frequencies that AT&T and Verizon, who are the two telecommunications companies that are impacted by this, they received permission from the FCC, which is the Federal Communications Commission, via an auction. They auctioned off those frequencies that are now causing this overlap between the radar altimeters and telecommunications. And that happened in 2019, I believe it was. Prior to that, RTCA was rewriting a radar altimeter standard to avoid this problem. But the auction happened quickly and the rollout of the technology was going to happen rather quickly. And so rather than writing a standard to avoid it, they had to describe what the problem was. And there was a lot of testing that went on. It was a very extensive report. A lot of that testing was validated by the FAA, by equipment manufacturers. They found that, yes, there was an interference problem. So then the committee started to focus on how can we need to slow this down and we need to convince everyone that there is a real problem here.
Right now, only America is dealing with this problem. But that doesn't mean there isn't some cause for concern, according to David Stupples, a professor of electronics and radio systems. Did you think problems would arise because of 5G?
Now I've looked at it in detail from America, I think in Europe we should be re-looking at it and perhaps doing some experimentation to ensure that safety is not affected.
So we know the altimeter uses radio waves, but why is 5G interfering with these radio waves in America?
What's happening is as people want more and more data with their smartphones and their iPads, their et cetera, we need more bandwidth. We need to be able to get more data down to the public. And also, a lot more people will be using it. Well, with 4G, we've just run out of bandwidth or running out of bandwidth. And we really can't support that. The connectivity for your 4G, the one that most people are using around the world, is around about 700 plus megahertz. That's per second. So that's a frequency that's been around for some time and the mobile phones are using. But to be able to get into 5G, we need to move this up into the gigahertz. That's 1,000 megahertz or 1 billion cycles per second.
In America, the majority of 5G tech operates within a range of frequencies that are too close to commercial aviation and air traffic control frequencies, according to the US Federal Aviation Administration, or FAA. In this graphic, you can see the red line where the radio altimeter is working between 4.2 and 4.4 gigahertz.
If you look at the top of that, you'll see America, and it is very, very close to the top of that band. It's almost there, and so is Canada. But if you look down the list, you'll see then you've got the UK and then China, and you can see that they're towards the middle of the band, so they're not really going to affect it. And this is also true of Germany and France and most of Europe.
Even though the frequencies don't overlap, there is a possibility of spillover where a 5G signal interferes with the altimeter. The FAA's main concern is cellular towers and antennas near airports. Canada has already designated 5G exclusion zones around airports, and antennas must be tilted down away from flight paths. And in France, regulators limited the power and height of 5G antennas.
personally, I would like to see Europe have a look at this as well, because this is very close.
Let's go back to America. The aviation industry doesn't want to stop 5G. It's a matter of finding a solution that works. For example, the FAA and the telecommunications industry have agreed on 5G buffer zones around dozens of airports. And now the Radio Technical Commission of Aeronautics is focusing on rewriting the standards.
It will update the minimum operation performance standards for a radar altimeter to narrow that frequency band that is going to cause interference with the radar altimeters. And we hope to eliminate the vast majority of this problem. So we are working to make sure that the standard is written as quickly as possible so manufacturers can build to that standard and then they can deploy it into the field. So we will need the cooperation of the telecommunications industry, but we understand that aviation has to do its part too.
Thanks so much for watching. Don't forget to like, comment and subscribe, and hit the bell button below for notifications. We'll see you next time.